Hi guys, welcome back to Bookmasters Academy. For today, we'll be looking at questions on metrics. This is a continuation of our physical class at Bookmasters Academy. So we'll be solving questions from chapter 8, New General Mathematics, book 3, chapter or exercise 8E, number 12. Also be solving question from 8H, number 11 and number 12. So don't go anywhere. Stay tuned and enjoy. Into matrix M and matrix N, 2 by 2 matrix in both cases, and we're asked to carry out a couple of operations: Mn, Nm, M squared, and N squared. This is a very simple one, so let's just try to see what we can do here. For matrix multiplication, all the operations are basically multiplications, and for M squared, N squared, just M times M and N times N. Now, one thing you must know about matrix multiplication is that we do it row to column. So we do row 1 to column 1, row 1 to column 2, row 2 to column 1, and row 2 to column 2. So just row to column. So if I'm to underline the first row, so you have your first row to first column, you have your first row again, still 6 0 to second column, then you have your second row to first column and second row to second column, something like that. We're going to see how we practice that down. We're going to use that right now. Let me just try to clean this. What we're going to do is this. Okay, solving question A, we have Mn to be equal to 6 minus 1, 0, 2 times 1, 3 minus 2, 5. So this is what we have, and I'm going to multiply it row to column just like I said. So we're going to do 6, which is the first row. This is our first row, this is our first column. So we'll do 6 times, we'll have our big set, big matrix. We'll do 6 times 1. That is 6 times 1 plus 0 times 3. 0 times 3. Like I said, first row, first column, 6 times 1, 0 times 3. So we'll put our plus, additional sign. So that's exactly what we're talking about. Still first, we've done for first row, first column. So we'll do first row again, second column. So in that case, we'll have still 6 times minus 2. We'll give a space for the second item in the matrix. 6 times minus 2 plus 0 is what I'm doing. 0 times 5. 0 times 5. So we're done with the first row, first column, first row, second column, and that's it. So let's continue. We have our second row, first column, and second row, second column. So that's what we're going to be doing now. So we have minus 1 times 1 plus 2 times 3. Good. So this times the second row, first column. So we're going to do that again, and we'll have minus 1 times minus 2 plus 2 times 5. Second row, second column. This will give us 6. When you simplify this, you have 6 minus 12, 5, 12 That's the answer to question E. That's the answer to question E. As simple as that. Simple as that. Question B, they say we should find NM. So let me write that down. NM. NM is equal to 1, 3 minus 2, 5, 6, 0 minus 1, 2. So we'll repeat the same process. Row 1 multiplying column 1, row 1, column 2. Then we'll go again, row 2, column 1, row 2, column 2. As easy as that. So let's do that real quick. We have a big matrix. Then we'll have 1 times 6 plus minus 2 times minus 1. That is this and this. So for the other side, would have 1 times 0 plus 2 times minus 2. So we can interchange the signs of these two. We're just having minus 2 times 2. We can do 2 times minus 2 for this. Any of them. Row 2, column 1. We have 3 times row 2, column 1. 3 times 6 was 5 times minus 1. Then 3 times 0 plus 5 times 2. So that's it. At the end of the day, when you simplify this, when you simplify that, you have 8, 13. Then this will give you minus 4, because this times this is 0. This is minus 4. So minus 4, 10. So this is it. Let's move to the next one. Next one is m squared. You'll be doing n squared. We'll just do for n squared, and that will be all for my end for this question. So solve the next question, because it's basically us doing the same thing over and over again. It's not a big deal. So for m squared, we have m squared, same thing as m times f. So if you want to write that down, we'll put down 6 minus 1, 0, 2 times 6 minus 1, 0, 2. So we're multiplying these two sets. We're multiplying it, and see what we make out of it. Just as usual, row to column, will not be stressing on this, believe you. I've noted the steps. So row to column, we have 6 times 6 plus 0 times minus 1. 6 times 0 plus 0 times minus 2, so times 2. We have minus 1 times 6 plus 2 times minus 1, minus 1 times 0 plus 2 times 2. Good. So that will give me a set, 2 by 2 sets, 2 by 2 matrix rather, sorry. 36 minus 8, 4. So that's what this will give me, applying board mass. So when you apply board mass, you're going to get this. Please, you try number D. Make sure you do D, and send us your answer for us to give feedback. So for the next question, let me bring it up. Yes. So this is for the next question. And it says, find the value of x for which the matrix has no inverse. The matrix has no inverse. Okay, first thing I like to point out is this is a very simple one as usual. Secondly, a matrix that has no inverse, determinant is 0. The determinant is 0. So in a matrix that has no inverse, you don't have a determinant. Determinant is actually 0. The value of determinant is 0, since it has no inverse. Good. So Find the value of x for which the following matrix has low inverse. So that simply means determinant is 0. So how do you find determinant of a 2 by 2 matrix? You multiply the diagonals and you subtract. You have matrix A, B, C, D. The determinant of this matrix would be A times D minus C times D. As easy as this. So let's apply this to our work. Let's apply this to our work so that we'll have the answer. So for the first one, which is A, let's put the matrix down. 8x, 8, 7, 2. Yes. So the determinant is 0. Good. So to multiply, we'll have 2x minus 7 times 8 equals 0. Out to x minus 56 equals 0. Then you simplify by taking to the other side 56. You have 2x equals 56. X is equal to 28. That's all for that question. For the next one, we have B. So let's do for B. For B, we have x 2, 8x. As usual, let's do this. We have s squared minus 16 equals 0. X is equal to 16. S squared is equal to 16. S equal to, find the square root of both sides. S equal to root 16. This would give you plus or minus 4. Plus or minus 4. When you take the square root, that's it. It's not a big deal. We're going to the next question. Good. Question C. X minus 2, 1, x minus 3. This is also very simple. To apply same approach, no changes to approach. We have x minus 2, s minus 3. Yes. So minus 2 times 1 is 2. So we have 2 equals 0. Fine. So what we're going to do, we'll just expand. Yes, that's how we do it. So s times x, s times 3, minus 2 times x, minus 2 times 3. As simple as that. So we should know this. So at the end of the day, we'll have x squared minus 3x times s times minus 3 minus 2x times minus 2 times x plus minus 2 times minus 3, which will give us plus 6, and minus 2 equals 0. This will give us a quadratic equation, which is, we already have a quadratic equation actually, but one that we're familiar with. We have this. Yes, we have this. As usual, solving quadratic equation using a factorization method. We try to find two numbers that will add, and it will give us, if we add it, we get the middle number. If we multiply, it will give us 4x squared. So find two numbers that will do that. So if you check, I think minus 4x and x, if you add both, and minus 1x, let's just do minus 1x. If you add both, you have minus 5x. If you multiply both, you have minus 4x. If you follow your normal methods for quadratic solving using factorization method, we're going to replace 5x with minus 4x and minus 1, or yes, and minus 1. So we have x squared minus 4x minus 1x or minus x plus 4. So that's what we have. Just basically replaced. They will find the factors, common factors here, and that's what we call factorization method. We have x, open bracket x minus 4. Yes. Then we have minus 1 is common here. So we have minus 1 minus 4 again equals to 0 equals 0. That's fine. So at the end, we have our two factors as x minus 4, x minus 1 equals 0, which can be written as x minus 1 equals 0, or x minus 4 equals 0. Our final answer is x equals 1 or x equals 4. We'll be solving question D for us. We'll be sending that to us. So for our next question, we'll be solving the number 12. Number 12. Yeah. For number 12, we're asked to find the inverse of the matrix M. The matrix M, we have to find the inverse of matrix M. Very interesting. And matrix M is 3, 5, 2, 4. 2 by 2 matrix. Yes, that's the first question. And they say we should solve the matrix equation mx equals to c, in which, good, so we're supposed to get the value of x, we're supposed to get the value of y. That means we should solve. And c is 1 over 3. We're going to see what we can do about that real quick. I'm not going to be taking time for that question. Very easy one too. So let's see what we can do. For the inverse, m is 3, 5, 2, 4. Good. A formula for inverse, usually inverse is 1 over determinant of that matrix. That is 1 over determinant of A times the transpose of the cofactor, which is times the adjoint of M. Adjoint is the transpose of the cofactor. The way you get the cofactor for 2 by 2 matrix is different from the way you get the cofactor for 3 by 3 matrix. So the principle is you should know how to get the cofactor. Then when you get the cofactor, you now find the transpose of the cofactor. When you get the transpose of the cofactor and you work with the determinant, you will get your inverse. So at every point in time, when you see inverse, do you know how to find the cofactor and the transpose? Once you know these two things and you know your determinant, that's the only way you can go forward. So with this, let's, first of all, the determinant is usually the first catch. Let's try to find our determinant, but I would like to write the formula actually. So A inverse, or let me do M inverse, since it's M. So do M inverse is 1 over determinant of M, or let me use the common symbol. I think this is its determinant of M times adjoint of M. But the adjoint is of M is equal to the cofactor of M transpose. So you find the cofactor, then you transpose it. So that's it. So for the determinants, usually we have said this, just you multiply this and this, multiply, you subtract. When you do the first multiplication, you subtract by the second multiplication. So for our determinant, we won't be taking time. We have our M Now for cofactor of 2 by 2 matrix, let me just say this before I point we solve this. You can actually get the inverse of the matrix of M without going through all this long process. There's actually a very short thing that we can just do and get it without going through the whole cofactor, transpose of cofactor and all that. But it's also right. It's also right you know how this is done properly so that you know the applications, you know what you're doing, you know the endpoint, and you know how to shorten it. For cofactor of 2 by 2 matrix, precisely our matrix, our matrix, our matrix M, which is 3, 5, 2, 4. So how you go about 2 by 2 cofactor is that normally you exchange these two. You exchange these two, then if this is your A, this is your B, this is your C, and this is your D, you exchange A and D, and you exchange B and C. Then after exchanging, you then give negative signs to whatever you get when you exchange B and C. So what I'm saying is this. See what you're going to have. 4 minus 2 minus 5, 3. So I exchange A and D, and I exchange B and C. And after that exchange, I now put signs for B and C. As you can see, that's exactly what I did. Good. So that's the cofactor of your 2 by 2 matrix. And transpose is basically you trying to turn your rows to column and your columns to row. So what I'm going to do is this. For my column 1, which is this, I'll just convert it to like a row, and that's it. That's what it means to transpose. So I'll be having my let me clean this. What I'll be having next is cofactor transpose of a cofactor. Then I'll have, yes, 4 minus 2. That is changing the first column to the first row. Then I'll do the same to the other one, which is minus 5 and 3. Good. So that is the cofactor of my, yes, that's the cofactor of my matrix. That's the cofactor of my matrix. Now, sorry, that's the transpose. That's the transpose of the cofactor. Transpose of the cofactor. Now, one would say, okay, why go through this long process? Yes, it's necessary, you know, because if I'm giving this question and I don't want to go through this long process and I want to just go straight to the point, we already have our formula for M inverse as 1 over M times adjoint, because this is adjoint. This is adjoint of M. This whole thing is adjoint. So adjoint of the cofactor. Adjoint of adjoint. Adjoint is basically the cofactor. So adjoint of M. Yes, adjoint of M. That's it. So adjoint is the transpose of the cofactor. So this is it. This is it. So what we can just do, if we have a question such as this one, and we already know our determinant, we want to just find the inverse, we just do 1 over our determinant times, let me write this M down here so that you see exactly what we'll do. 2, 4, good. So what you just do is you exchange this 2. So after exchanging this 2, then you put the sign here and here. That is just it. So look at it here. You exchange A, B, C, you exchange A and D, then you put negative signs for B and C. That's just it. That's how you get the adjoint without stress. But we're just giving you all this long process that your cofactor is basically you exchanging diagonals, then putting signs for this, putting signs for here and here. Then after which your adjoint, yes, the transpose of the cofactor will help you to return back to this. And the shortcut is when you have your matrix, all you just need to do is to, if you want to find the inverse of your matrix, if you want to find the inverse of your matrix M, just exchange A and D. After exchanging, put the sign. This will give you adjoint automatically. So you have 3. Yes, sorry. After exchange, you have 4 minus 5 minus 2, then 3. So after the exchange, that's what you have. So that's it. If you want to get the adjoint, this is the adjoint of M. This is the adjoint, just adjoint of M, as quick as possible. So without going through this whole step, but it's necessary you know how things are done. So all you need to do is to divide each of the elements in this matrix, each of the items there, divide it by 2, and you get your final answer. And that's just it. For the first part of that question, which is just about getting the inverse. So for the second part, let's try to do the second part, which is also very simple. The second part, For the second part, let's see. They said solve the matrix mx equals to c, mx equal to c, in which x is a 1 by 2 matrix, or 2 by 1. Okay. Same thing with C, 1, 3. So this is it, and that's how we should solve. The aim is to get x and y. How can we go about it? So one of the techniques we can use here, I will just introduce something. First of all, it's important you know this, that it's important you know that if I multiply M with the inverse, which is this, to give me an identity matrix. An identity matrix denoted as this. Good. And yes, if I multiply M with an inverse of N to give me identity matrix, and identity matrix times any matrix, let me just say times A, would give me E. Get identity matrix times any matrix at all would give me that matrix. So having said that, let me introduce some stuffs that will help me to solve and get my X, get my Y. Because as I can see, the problem is this M. The problem is that M right there, this A. Without this N, these two matrix are equal. They correspond. So you can just call this, assuming this M is not there, you can call your X1 and your Y3. But because that there is an M, I want to eliminate that M. And I'm going to use this simple approach I showed you now. I use that approach. And the approach is this. I would write M minus 1 times mx equals, if I'm introducing this to the left-hand side, I'll be sure to introduce it to the right-hand side. So that's just the principle there. So times C. That's nice. So what I might have is this. I'll be having my but remember, inverse is determinant times adjoint. I think I have my adjoint somewhere around here. 4 minus 2, minus 5, 3. Yeah, that's why I didn't clean it. So that's it. So I have my adjoints. So I'm going to do 1 over 2, 4 minus 5. That's my adjoints. Minus 2 what? Minus 2, 3. That's 2, 3. So that's it. Then that's for this, that's for this, that's for that. Then I have my M. My M has not changed. Still there. Still the 5, 2, 4. Yes. Then our X is given to us. X is X and Y. It's looking large, but it's still nice. Let me move the screen a little bit. I have my 1 over 2. Yes, still that inverse matrix again here. I have this 4 minus 5 minus 2, 3 times C is 1 over 3. C is 1 over 3. So I have 1, 3. 1, 3. Nice. So please, you're not going to be doing this. That's what's in your mind, because that would only take us back to this, and believe me, you don't want to go back there, because that's the problem. That's the problem we're trying to solve. Yes. So what we're going to do now is we're going to multiply this matrix. Multiply that matrix, then we'll multiply this 2 matrix as well. So let's do that real quick. It's not a new thing, so we're not going to waste time. Just going to write down everything, or maybe I'll just write down the final answer, since we've done quite a lot of things, quite a lot of operations in multiplication. I'll not be doing that. You just try and do that on your own. If you multiply, so this video will not be that long. If you multiply the first matrix and the second matrix, you'll be having 2, 0, 0, 2. And you have X, you have Y. So that's what you should have when you solve correctly. Minus 2. Okay, we didn't do multiplication. This is 2 by 2. This one is 2 by 2 times 2 by 2, and that's what we did. But since we did not do this one, I would like to show you how you do it. So this is the same thing. We have row to column, then row to column. Gets. So that's it. Let me show you. So we'll just have, at the end of the day, let me show you what I'm saying. Let me do 4. We'll do 4 times 1 plus minus 2 times, so plus times minus, is minus 1. That's just that. So we'll have that. So this times this plus this times this. So there's nothing to write, to use and multiply. There's no column 2. So we'll just close our bracket. We'll do again. This times this times this. And that will be all, because there's nothing again to do. So we'll have minus 5 times 1 plus 3 times 3. So this should give minus 1 over 2 minus 2 minus 2, 4. Good. When you simplify properly. Then this side, let's just leave it like that. Or, okay, let's leave it like that for now. You have 2, 0, 0, 2, x, y. So let's use this 2 to multiply each element, so that 2 divided by 2, 0 divided by 2, 0, and all that. You have 1, 0, 0. And this looks familiar. This is an identity matrix. Very, very familiar. We have x, y equal to minus 1, 2. So this is it. And just like I said, any matrix multiplying the identity matrix will give you that same matrix. So you can try that later, but we don't have time. So therefore you have x, y to be equal to -1, 2. That's perfect for us. That was our answer for this question. And that would be all. That would be all.